Next, we're going to learn how to graph a quadratic function. If you look at this function here, there's not much that you're familiar with. So let's see if we can pick off any parts of these critical points that we might be able to figure out. So we need a vertex point, we need a y-intercept, and we'll eventually need to find an x-intercept or multiple x-intercepts. This number up here will indicate how many possible x-intercepts you have. So in a quadratic, we could have up to 2. If you think about a quadratic, we think about its standard form as f of x equals ax squared plus bx plus c, where a, b, and c are coefficients, like in this case a is 1, b is -6, c is 5. Standard form, obviously, because we're going highest exponent to lowest. And our constant's our last one. When we think back to linear functions and we think about our constant, that was our y-intercept at the time. So in this problem, our y-intercept would be 0, 5. Right? The last number, the constant, just as it was in linear functions. So when you're in standard form, this is your y-intercept. Now obviously you could prove that by plugging in 0 for x and you'd still get out 5. So we'll plot 0, 5 on the graph to start. No other information is readily apparent to us, so we need to try and find something else here. Either the vertex point, the axis of symmetry, the x-intercept. We'll start with the vertex point. You find the vertex point by using this formula here, where if we're talking about a standard form quadratic, it's -b, or the opposite version of b, over 2 times a. b and a are coefficients here. So for example, I just chose 3. Say my answer for this was 3. When I put the opposite version of my b coefficient over 2 times my initial coefficient of a, I get 3. What I mean by this, by f of -b over 2a, is just taking the value you got for x and plugging it in for x to find the y value. It sounds more complicated than it is. And also the axis of symmetry is the x value of the vertex. As we mentioned in class, the vertex point is where our graph will either go from increasing to decreasing or decreasing to increasing. So it's not surprising that the graph is going to be cut in half right about there. So in this case, let's find the vertex point. X equals the opposite version of b. So if b is -6, the opposite version is +6. In this case, a, our leading coefficient, which is what you call the first one you see, is 1. So 6 over 2 times 1, x is going to be 3. So that's the x value of our vertex point. We have to find the y value at that point. So we'll plug in 3 for all of our x's. So f of 3 is 3 squared minus 6 times 3 plus 5, and that's 9 minus 18 plus 5. So f of 3, our function evaluated at 3, is going to be -4, and that's our vertex point. Let's plot our vertex point, 3, -4. And what we just said is that this is our axis of symmetry, the x value of our vertex. It's right on that point. So the axis of symmetry is actually a vertical line. If you think back to the linear functions unit, when we have x equals a number, that produces a vertical line, thus our vertical line that cuts our parabola in half. In this problem, when we have to figure out if it's a max or a min for our vertex point, we look to our a term. So we look at a. If a is positive, it's a minimum. If a is negative, it's a maximum. So in this problem, a is a +1. So we have a minimum point here, which also makes sense because we've plotted a point, our y-intercept, above our vertex. Therefore, we must have a graph that's opening upwards. So the last piece that we have not dealt with yet is how to put our x-intercepts on the graph. I know this says really small, but we have to find x-intercepts. We only have 2 points. We need to make it u. This is not going to work for me. So what we do is something called the zero factor property. What you're going to do, as you realize, for the x-intercept, y equals 0. So we're going to go ahead and plug in 0 for y, just like we did in standard form in the linear functions unit. Plug in 0 for y, solve for x. We have no other way to solve this quadratic at this point other than factoring. So we find what multiplies to 5 and adds to -6. And that's going to be -5 and -1, right? This is just a little a equals 1 trinomial. When you're here, this only really gets me so far. These factors are good, but I still haven't solved for x. So to make this 0, either one of these could be 0. So let's just set it equal to 0 and solve for what values of x, if we plug them in, would produce 0. Because remember, if this is going to be equal to 0, 0 times anything is 0, or anything times 0 is 0. So one of them must be 0 at least at one point. So our two x-intercept values are 5 and 1, and remember we want to write those as coordinates. There's definitely a lot here, but it's nothing new outside of maybe the vertex point. This factoring, something you've been used to doing all along, you just find the factors and then set them equal to 0 and solve them. You produce your two x-intercepts. We have one now at 5, 0. And 1, 0. Notice they're equally distant from the axis of symmetry. There's 2 blocks there, there's 2 blocks that way. So this is great. We could probably make a parabola here, but since this is your first time really making one, what I want to do is plot more points. So I notice that this is 2 away here, this is 2 away here. This point is 3 away, and we know that it's symmetric because this is called an axis of symmetry. So what happens on one side must happen on the other. So we have a point at 0, 5, which is 3 away. We go 3 more over and get a point at 6, 5. Notice 3 units away from the axis of symmetry at the same height. So we're pretty close to having a nice looking parabola to work with. The other thing you have to remember is in a parabola, you square numbers. So if I went over 1, I'm squaring 1 and I'm getting to 1. If I square 1 on the other side, so -1 squared is also 1. Thinking about that and extending it over here, go 2 over, it's up 4. Go -2, it's up 4. 3, 9. -3, 9. 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Same idea. So if you square a number, it will move accordingly. The only time that would change is if your a were not 1, and you'd have to not only square it, but then multiply it with order of operations. And here, through all that, we have produced a parabola. Again, it seems like a lot, but if you follow the process, it's not that difficult.